All right, for our final presentation, uniformity measurement in cinema, we have two presenters, François Helt and Hans-Nicolas Locher. So François has a background in semantics, filmmaking, and mathematics, and has over 30 years experience in professional video and film. He started as a video artist, and now he is technical manager. He was also technical manager of the European project Limelight, aimed at the design of a complete digital film restoration system in the late 90s. He was founder and CEO of the Dust Company, specializing in digital restoration and processing of film from 97 to 2002. He's the author of Automatic Digital Film Restoration Software. Also was technical director of Do-Re-Mi Technologies, chief scientific officer of Highlands Technologies, and also scientific consultant for Eclair Laboratories since 2017. He's the designer of projection measurement system, and current interests include visual perception methods, measurement theory, and philosophy of information. Our other speaker, Hans-Nicolas Locher, he's Director of Development at the Commission Supérieure Technique de l'Image et du Son, yeah, nice, CST in France. He's a development engineer, and he's worked for years in the projection operation and with research laboratories such as Cedric and IRCAM. He implements software tools for testing and validation of digital cinema files and is the architect of the information systems for monitoring the projections for the Cannes Film Festival. He is involved in the standards process as AFNOR Commission member for CN 204. And he's editor for the CNTC 457 project team, Digital Preservation of Cinematographic Works. And finally, he is convener of WG4 Presentation Technologies in the ISO Cinematography Group and has chaired the IMF Application 4 project at SMPTE. Please welcome our two great speakers.
Hello, thank you, Molly. So I'll start with the first two slides. There are two mottos here. They are contradictory, but the two people mentioned here were talking about statistics. Mencken was a high critic of statistical applications, and Gibbs contributed a lot to statistical computations. So I'll let Hans-Nicolas.
So yeah, I have to explain you the French cinema part of the title. So I will present you shortly CST. So that's the French Association of Film Audiovisual Technicians. We have less members than SMPTE, but still about 600. And as SMPTE, we took work groups into the membership and produce recommended practices and other documents. So we help in establishing the French standards. And one of the historical missions of CST was the conformance control in cinema room. So we have some data on screen measurements that we will talk about later. So we have some other mission as consulting cinemas, and we manage the screening activity of the Cannes Film Festival. So sometimes we have some American director asking us to use 35 projectors. And so we have also some partners. So, but the important part of this is that we took at CST some work group for preparing the work for AFNOR, because we will spoke in one slide about the revision of the two standards we use in France. So AFNOR is a French standardization body, and especially the S204 Commission is committed on cinema. So it's presided by CNC, CNC is a French agency for cinema that funds CST, by the way, and some interprofessional composition with CST laboratories, cinema chains, and the French Theatre Owner Union. So, but the topic is we are about to revise 2 of the French standards about cinema. The first one is NF S27 It's about architecture and will integrate some acoustics in the next revision. But the one we are speaking about today is NF S27-100, and it's about reproduction, so to say, about projections today and maybe some other displays in the future. So it includes image ratios, peak luminance and other measurements, and especially formulas for luminance spread and uniformity. So the revision was open at the end of 2018, and we are in an open state of the discussion. So we want to have we want to explore possibilities and refining some measurements, some metrics that we use today. And as we know that we are not alone in the world, of course, we look closely at the SMPTE standards too, of course.
Thank you. So this slide is more or less related to the previous presentation by Stelios. In the course of trying to find basis for the revision of our norms, of our standards, we looked at different things, and this is a presentation, a very short presentation of one investigation. Same topic is the maximum luminance accepted, and we based our research about the famous model by Barton, who shows that the sensitivity of the visual system is increasing, but increasing less and less as you go higher in luminance. So we have the vertical bar here that are showing. The first one on the left is the one by Digital Cinema, so it's 48 count per square meter. Then you have the 200, hundreds, and 103 and 108. Then 300 and 500. You see that there is not much difference between 300 and 500 in terms of sensitivity. So as peak luminance is related to the electrical consumption, maybe it's not worth spending so much energy going to very high luminance. So the paper here is about uniformity. There are 2 counterexamples that were designed to fool the current luminance and uniformity equations that are found in the current standards. Of course, the images are showing examples of these possibilities. It's not there are various possibilities. But it shows that if you respect the tolerance expressed in current standards, you can have visually something which is not uniform at all. So we looked for a different formula with following certain guidelines. The formula should be the same for projection and the new coming direct view display. The luminance spread formula should be similar to the EBU proposal, because there is the coming of direct view display, which are quite similar to flat panels, and the EBU has proposed some measurements, some equations, some methods to measure the uniformity. Then the uniformity should be derived from statistical calculus, and as simple as possible, but more complicated than the very simple formula that are found in the standards today. And also, as the peak luminance is varying and there are new proposals for new peak luminance, there must be a certain linearity in the formulas. So there is a difference between the projection and the view display, and projection is showing vignetting. There are different kind of vignettings, and vignetting can be changed by using different lens system. You can improve slightly the natural vignetting that is shown by things, but knowing at least what is called the throw ratio, that is the ratio between the projecting distance and the screen width, then you can compute the vignetting proposed by projection and correct it. So the idea here is to have the same formula once the projection systems are corrected. Vignetting correction is usually, that was the previous slide, is usually modeled by a power of 4 of the cosine of the viewing angle. So it starts to be difficult to compute it. So there is an approximation that is proposed, which is based on the throw ratio, and which is quite simple. As you see it, as the correction is 1 plus a certain ratio, a coefficient divided by the throw ratio elevated to the power of 2. So those corrections, as you have a few numbers of measurements on the screen, then this correction can be computed from table. So this is a proposition of a table. What are the measuring locations to try to have the same kind of control work? To limit the number of measurements, there is a possibility to have only 9 measurements. You were traditionally, there was the ANSI setup with the measurements at the center of the 9 rectangles here, or the ISO proposed pattern that is using measurements that are closest to the borders of the screen. There is a EBU pattern, which is close, very close to the ISO one. At least the location on the periphery are very close to the locations in the ISO pattern. And the tolerance is expressed in EBU documents, and it's 5%, plus or minus 5%. In the document, it is said also that you can work with only 9 spots instead of 13, and you keep the periphery and the center. So what is there are the 2 values to estimate the uniformity. One is the luminance spread, and the other is uniformity by itself. So the spread value estimation, in the current standards, the spread value was measured against the maximum luminance. It is quite natural for a projection, as there is a vignetting effect, and the luminance is decreasing from the center to the sides of the screen. So in the standards, the limit is 25%. Here, with random generated values, you can see that the old formula is giving 23%, and the new formula is 25%. So the new formula is based on a reference to the average, not the maximum. That doesn't change much, the value, but it's more in line with the EBU specification. So the formula for the spread value, there are a few formulas in these slides. I mean, if you want to have more information, go to the paper. You have the formulas on, and you have time to look at the formulas there. So the formula is the same for direct view display and projections once the measurements in the projection system have been vignetting corrected. And the tolerance in the current standard is 10%. It's 25%, sorry. Here, 25 is the whole range, between the maximum and the minimum. The EBU is expressing the tolerance with a classical statistical estimation, which is plus or minus something. So we are going to the uniform expression by itself. A perfectly uniform system should have values that are only based on random variations by the physical thing, the measuring instrument, and the actual capacity of the reproduction system. So it's a random variable, and the classical law for this kind of statistical distribution is called the normal distribution. So when you have a normal distribution, standard deviation is something which is a normal way of measuring the width, the smoothing of the distribution. And this is what was proposed by, in a UBU document about uniformity. So it was proposed to use standard deviation. But if your projection or display system is not uniform, it means that you don't have a uniform distribution. You don't have a normal distribution. So what you must measure, if you want to measure, to estimate uniformity, is how much the measurements are away from a standard distribution, so the normal distribution. So there are a lot of different formulas for distance between distribution. One of the simplest formula is they call the Kolmogorov test, or Kolmogorov-Smirnov distance. It works between any kind of distribution. It is simple to compute. You only have to sort the measurement in ascending order, and it applies to continuous value. That is, value that you cannot put in bins like the age or things like that. And the distance is always expressed as a ratio between a ratio in percentage of the spread. So you have different normal distribution that are varying standard deviation, and the exact distribution to choose depends on the number of points. Here you see some shapes of normal distribution in function of the number of points. So as we have only 9 points, we have a very smooth distribution, and it's not very different. The normal distribution is not different from the uniform. Using the uniform distribution gives easier computation, and it is not that far in terms of estimate from the real normal distribution. So that's what is proposed here. This table is showing on top, you see, with the images that are on bottom, you see that the standard deviation is giving something wrong because it says that the visually non-uniform image patterns are better than the one that is almost uniform. But the new KS measurements is giving an estimate which is better in this case. And the small graphs are showing how you compute the distance. So how that can be combined in the standards, the proposition, it is a proposition. The Cinema Commission has not decided yet. So the proposition is to mix the uniformity and maximum spread, and that the spread, the maximum spread is a mandatory, and that quality classes are derived from the uniformity measurements. Proportionality, just to be quick, you have to have the same formula must apply for standard digital cinema, ADR, HDR, whatever. And again, we are using the same Barton model to show that the tolerance is much higher, much more tolerance for higher luminance. This is a uniformity formula, so go to the paper if you want to see it. We had some results, so we were measuring 10 theaters, and we intend to measure 30 theaters to make comparison between the old formulas and the new ones. What you see here is that in terms of spread, the new formula is less tolerant than the old one. And in terms of uniformity, there is not much difference. Hopefully, the counterexample were not found in real life. So in conclusion, what we're proposing is a unique formula, which looks better than the old one, because it avoids false positives. The counterexamples were false positive. It applies to SDR, EDR, HDR, and to projection and direct view display. It's ready for further developments, but further developments will involve more spots, more measurements on screen, and you would spend more time to do the control. So the system is proposed as it is now. Thank you.
Thank you so much. I know everyone's eager for a coffee break, but does anyone have any questions? A really great presentation, good research. Thank you.
Hello, the name is Rod Evenson. I'm wondering if you might comment on the differences between anamorphic and non-anamorphic projection. I know that most illumination sources for a projector are circular in nature, but then you put it through an unsqueezed optic, and that would change, as I would see it.
Thank you for your question. Frankly, I've not looked into it, but I think that if a projection is uniform, being anamorphic or not, it will be uniform. So I have to look at the exact numbers and how much that changed the values. But the formula should be good anyway, because it's a distance between one distribution and the real distribution of values you have.
Francois, Hans,
Hello,
hello,
CG.
well done. The question I was wondering, in your practical applications, did you try and tweak the projectors? And what is necessary to bring them up? Do you need new lenses? Do you need to work with the mechanics inside the chips, or what do you recommend? And
Okay.
is it possible widespread?
Yeah, the guy in CST, which is in control of the theaters, is using a simple, very simple spreadsheet that I've proposed, and the spreadsheet can be proposed to anybody. It's not a problem. The only difference with the usual control is to have a value for the throw ratio. Other than that, controls are exactly going the same. And the values, the estimates are given by the spreadsheet. The exact computation, simple, is given in a paper at the end. Thank you.
Thank you.
Any more questions? Great. Thank you guys so much for your hard work.